And at this point, we've piled up, quite a few assignments that we've been working on. Zach?
So you can ask questions from like.
Oh yeah, of course.
Okay. You do number 5 on the problem side.
Sure. All right. So here we're asked to find the amplitude, period, frequency, and then graph the thing. So I would start by identifying the values for A, C, H, and K. From the form it's written in, I can identify really quickly those values. Any questions on how I did that? Okay. So I know that the amplitude is the absolute value of A. So that's 2. I know the midline is y equals k. So that's just y equals 0. I know that the period is 2 pi times c, or times the absolute value of c. So that's 4 pi. And I know the frequency is the reciprocal of the period. So 1 over 4 pi. So far, so good? Okay. To graph this then, I'm going to start by writing my transformation map. So that transformation map is always Cx plus H, Ay plus K. So in this case, I have 2x plus 0, comma, 2y plus 0. I'm going to not write the plus zeros. And then I'm going to use the key points from sine. So if we go back to our notes on 10.4 is where we gave you guys that. Maybe it's 9:30. Yep, right there. So I'm going to use those 5 key points. That would be something that I provide to you. You're not expected to have those memorized. Zach?
When I was looking at it, it said through the something. What did that mean?
We'll get there.
Oh, that's
Yep, we'll get there. So if we're graphing, this is always the place that we start, regardless of the interval that we're graphing over. So these are our key points. And so I'm just going to take my x and plug it in for x and simplify, then take my y and plug it into y and simplify. And I'll do that for each of these 5 key points. So far, so good. So now let's go ahead and graph. So it asks us to graph on the interval from negative 4 pi to positive 4 pi. All that's really telling us is when we write our, now come on here. I don't know why this is insisting on being so small. Oh my goodness, I am so angry at you right now. Let's try it again. All that is saying is that when we go ahead and, there we go, draw our axes, it's just kind of telling us what the range on the x-axis needs to be. So basically I need to graph all the way back to negative 4 pi and all the way forward to positive 4 pi. Now, if I look at the x-coordinates that I have, they're just going up by pi's. So I really just need 4 tick marks on my x-axis, going up to 4 pi. and going backwards to negative 4 pi. And then we'll just plot. So 0, 0, pi 2, 2 pi 0, 3 pi negative 2, 4 pi 0. So that's that part. And now I should extend this graph backwards so I cover all the way back to negative 4 pi. So I'm just going to follow the same pattern so that it just looks like it's the same on both sides. And that's that. Oops, my goodness. That's better. Is that okay? So again, graphing over the interval is just telling you, like, this thing goes on forever. How much of it do you really need to see? How much should I show you?
I thought the interval thing meant that it was a different set of starter points.
Ah, no, you can still use the same starting points. You may have to extend forward or backwards more or less, but you can still, every time you're graphing, you can use that same set of key points. Follow-ups on this one before we move to something new. Okay. Natalie.
Can you do something in worksheet 2, either unit number 6 and explain the process?
Sure. So I'll just kind of start and I'll talk through what I'm doing. If there's at any point where you're like not sure, you want a little bit more or anything like that, feel free to stop me and just ask for a little bit more, and we can go into more depth if I'm kind of skating past something you're not sure about, okay?
Okay.
All right. So it says we want to find the equation of a sinusoid function. Yes?
Did you just ask me to move? You said it was a move.
Right. That's correct. I don't have a Zoom link.
Oh. Should I just tell you that they moved?
Yeah, the recording will be up. This is Sergio. Yeah, he asked me about this before he went on. And I told him that I was just gonna post the video links and there wouldn't be a Zoom. But that's all. Anyways, so here it says asks to write the equation of a sinusoid function. So that means it's either a sine or a cosine function, right? So what this problem really boils down to is either picking which one you want to do, and then finding the values for A, C, H, and K, and then kind of plugging them into the general transformation. Okay? So this one says the given information I have is I have a maximum value at negative 2, 10, and a minimum value at 14, negative 18. So I would start by just kind of plotting a little bit of what I have, because I think often a picture is quite useful in this sort of situation. So I don't know, I have negative 2, 10 is maybe up here, and then I have 14, negative 18 that's down here. And I'm told that the first point here is a maximum, and the second point is a minimum. Okay with that? And usually what I like to do before I get going too much further is I'm just going to kind of extend this so I can see like one full period. So I'm just going to draw a little dashed line to just extend that so I have a full period. Okay. So the first thing I'm going to look for is the value for K. So I know that the K value is like halfway in between these two things. So it'd be like, I don't know, somewhere over here, right? So what I'm basically going to do is I'm going to think about this as counting from negative 18 up to positive 10. And I'm just looking for the number in the middle of that. So you could like literally put it on a graph paper and like count like what number is halfway in between negative 18 and positive 10. Or what I prefer to do is I'm just going to take the average of those two numbers, because that's literally the number in between two numbers, right? So that's going to be 10 plus negative 18 divided by 2. So negative 4 in that case. And that's my value for K. Does that feel okay so far? The next thing I'm going to do is look for the amplitude. Well, I guess that's right. So the amplitude is like the distance from one of these to k. So you could just do this now again by counting. So if I'm starting at -4 and I want to go down to -18, I had to go 14 units down, right? But a is a distance, so it doesn't really matter up or down. We're just going to say that the absolute value of a is 14. Drake? Sure, no problem. Amy?
Is there any possibility?
Yeah, so that you can do it that way as well. So the other way you can think about, since we're talking about the distance, so you can take the absolute value of the difference in the y coordinates divided by 2. So half the distance. So again, that's going to be the same thing. That's going to be 14. Is that okay? And again, it doesn't matter if you're doing the absolute value, it doesn't matter which one you're doing first or second. Oftentimes I'll write it as like, I think probably in the notes I wrote it as y max minus y min. But if you just take the absolute value, it doesn't matter which one comes first or second. It's a distance, so it has to be positive, right? Yeah. So that's all we're saying there.
So that for that, finding a, you wouldn't need to look at like which direction the graph is going in.
Correct. We'll figure out the sign on a, whether I want to use the positive or negative when we look at h.
Okay.
But for right now, I don't know whether we're going to have a positive a or negative a yet. We'll figure that out in a minute. Okay? Sure. Okay. So we have k. We've narrowed a down to either positive 14 or negative 14. Next thing I'm going to do is look for c. To find c, I'm going to look at the period. So what I want to figure out how much of a period is it from that to there. So I'm just going to use my eyes. One full period is what I've drawn with the dashed line also. So this looks like a half. You guys agree with that? So then I can just count then. Oh, the period is the horizontal distance. So I just need to know how many units does it take to go from -2 to positive 14. So 16 units. Everybody's okay with that? Again, you can just think of that as counting. I think on the notes I called it like the x coordinate on the right minus the x coordinate on the left. Or you could just subtract the two x coordinates and take the absolute value. That's fine also. Still doing okay?
So half the period would be the distance between the first x coordinate and the second x coordinate?
Yeah.
Okay.
Yep. So you could literally go from, okay, I'm going from -2 to positive 14. That's 16 units, right? 2 units to get to 0, and then 14 more to get to 14. Or you can think about it, like the x coordinate on the right minus the x coordinate on the left. Or you can just like subtract the two x coordinates and take the absolute value.
Okay.
All three of those are doing the exact same thing. Doesn't matter which way you think about it, whatever way is easiest for you is fine. Some of them are easier to write down if I'm showing work. Some of them are easier to explain. Some of them are just like if I'm doing it myself and I don't really care about how much work I'm showing, like you can just kind of count. Okay. So if half a period is 16, then one full period is 32, right? And I know a period is 2 pi times the absolute value of c. So when I divide both sides by 2 pi, I have 16 over pi. And again, remember we say that we're always going to use the positive value for c. Not that there's not a negative or answer where there's c is negative, but in my experience, it's never easier to find the answer where c is negative. So I'm just going to, since there is an answer where C is positive, I'm always going to pick C to be positive and just find that answer. 16 over pi. Still doing okay? All right, so the last step, I'm going to decide whether I want to do sine or cosine. All of these values would be the same, what we found so far, whether you do sine or cosine. You don't have to figure that out at first. So we need to decide whether we'll do sine or cosine. We need to find the value for h then, and figure out whether the a should be positive or negative. Now in this type of problem where I'm given maxes and mins, the easier choice to make is to use cosine. My goal in doing this is I want to use a coordinate from the parent function where the x-coordinate is 0. So in cosine, that means I can use 0, 1. In sine, I could use 0, 0. Now, the catch is, in sine, 0, 0 is a midline point. And in cosine, 0, 1 is a maximum, an extreme point. And if I'm going to match these up to do a transformation, if I transform a midline point, it's got to turn into another midline point because I'm doing the same thing to every other coordinate, so it can't turn into a maximum somehow, right? And the same thing with a maximum or minimum. If I transform that, it's got to transform into another maximum or minimum because we're doing the same thing to all the coordinates. So any change that happens on it is going to happen with everything else, so it's still got to be a higher or low point. In this problem, we're given maxes and mins, so I want to use cosine because 0, 1 is also an extreme point. So the notation I use here is I say, okay, from the parent function, which is cosine, I'm going to use 0, 1, which is a maximum. And in my transform point, or transform function, I have my choice. I have 2 points I could use. I could use negative 210, which is a maximum, or 14, negative 18, which is a minimum. It doesn't really matter. It's going to change your answer, but both answers are fine. Let's just say, for the sake of argument, we use that very first one, which we said was a maximum. Everybody okay still? Okay, so we've decided it's cosine, right? We've made that choice. Amy?
So just to clarify, you said 0, 1 to be a maximum or a minimum?
So 0, 1 is a maximum, okay, but I can pair it with any other extreme point, a max or a min. It doesn't matter.
And then 0, 0 would always be a midpoint.
Right. That is correct. You're welcome. Okay. So we've decided we're doing a cosine function. Because we're going from max to max, that the type of extreme point remains the same, that tells me that the a is positive. So that tells me that a is 14. Everybody okay with that?
How do you determine the negative?
So because the extreme point is staying the same, that's why it's positive.
Oh.
If I had gone from max to a min, then the a would have to be negative.
Okay.
So if you're changing the type of extreme point or the type of midline point, that's when your sign on a is going to change.
Okay.
Emily.
So if you use the other point, like the minimum point, would it be negative?
Correct. That's exactly right. Jack? Same question. Perfect. Everybody so far so good? Still doing all right? The pace is okay? Yes, Emily. Or Katie, sorry.
Okay. So 0, 0 is a
midline point, yeah. Or midpoint, yeah. Yep, that's correct. Okay. So the advantage of using a parent function point where the x-coordinate is 0 is the x-coordinate from the transformed function is going to be the same thing as my h. So that's why, in particular, I wanted to use either 0, 1 or 0, 0. is because I get the h essentially for nothing. There's no calculation to do. It is the same as the x-coordinate from the transform function. Now, why is that? Should we talk about that? Yeah, of course. So just at this point, this problem is ostensibly done, right? All we have to do is now fill these into the formula and we're finished, right? Okay. But let's address this question real quick. So when we graph something, we use this transformation map, right? Cx plus h, comma ay plus k. So what we're doing is we're taking a point, a coordinate from the parent function, its x-coordinate, we're multiplying by c and adding h to give us the x-coordinate in the transformed function, right? So in our problem, our a is 14. The x-coordinate from the parent function is 0, plus h should give us the x-coordinate from the transform function, which is -2. Anything times 0 is 0. I add 0 to h, it's just h. It's just -2. Ryan.
Why is it 14? Isn't it c x percent?
Oh, yes, sorry. Sure. Yes, I got, yep. Doesn't really matter because it still zeroes out, but yes, you're absolutely right. I did write the wrong. I put an A there instead of a C. Yes, thank you. Is that okay? And you could do the same thing if you had to find the K value this way. You could do the same thing with the Y coordinate to find the K. Does that make sense?
Yeah.
Okay. Jack.
So if we picked sine here, we would have had to do this kind of thing, right? And then instead of using the c coordinate, or the x coordinate for if we chosen sine, I have my notes like pi over 2. Does that still work?
Yeah, so if you had chose to use the sine function here, you'd have to use an extreme point from the parent function of sine. So you could have picked the maximum at pi over 2, 1, or you could pick the minimum at 3 pi over 2, -1. Either would be okay to use. But yes, that would, if you did that, since the x-coordinate is not 0, you would have to solve an equation like that to find the h. Yes. I'd recommend not doing that because this is so simple if just by picking cosine instead of sine. But if you wanted to, you certainly could.
Yeah.
And it would not be incorrect. Katie.
So I have a question about the period. Could I do 1/2 2 pi c equals 16 and do 1?
Yes, that would be perfectly fine. And you can solve that from there? Absolutely.
Okay.
Elvis.
What are the mid coordinates for cosine?
So that would be at pi 0 is the midpoint for cosine. Emily.
Do you have to only do the a cosine, like it's negative?
No, you have to do it with sine also, because there's 2 type of midline points for sine. Should we look at that real quick?
Yeah.
Okay. So this is like an aside here. So like this is a piece of sine, right? Let's say we're looking at this. Actually, let's do it colored. Let's say we're talking about this midline point. Relative to this midline point, there's a minimum on the left and a maximum on the right. If I look at this midline point, there's a maximum on the left and there's a minimum on the right. Elvis, I misspoke a moment ago. The midline point for cosine is this or this. My apologies. Look. you get a question you weren't quite expecting and then you stumble through, but at least I noticed it here. That would have been not great for you. So here's the thing, is we're not talking about translating between these. It would depend on the parent function, what's going on in the parent function. So like,
So it's the one point on like the transform function with like mid, midline, max, and then the point.
yeah, so if your parent function has this order to it, then your A would be negative.
Yeah.
If you're using 0, 0, which you would be, right? If it's the same as order 0, 0, then the A is positive. Does that?
Yeah.
And we're just getting it from looking at the picture, right? That's all I'm doing to kind of figure out what type of midline point it is. I'm just looking at the picture.
So it's like relative to 0, 0.
Right. Yes. Yeah. Is it having the same order as 0, 0, or is it the opposite order?
Okay.
That's all I'm checking. Amy.
Could you just explain again how you know when to use sign? I think it was like
Yep. So here are the 2 times when I would use sign for problems like this in worksheet, whatever number this is, 2. So if I'm given a point and I'm not told anything about that point, like it doesn't have to be a maximum or minimum or whatever, I'm using sign. So like numbers 1, 2, I think are both that situation. The other place I'd use sign is if the point that I'm given, I'm told is a midpoint. That's a case where I would use sign. If the point that I'm given is an extreme point, a max or min, I'm using cosine. That's the gist of it. Emily.
page number 8.
8? Sure. So I'm going to approach this almost exactly the same as I did 6. So I'm going to start by just kind of sketching a little bit of a picture on what I have. So I have 215, 8, negative 8. And then I'm going to sketch in the rest of it. Is that okay? Now here, the K is super easy because I know the K, or the midline, has to go through that midline point, right? That's part of what the midline does. It goes through the midline points. So I know then that K is just 15. For free. Cool. So far, so good. Okay. The next thing I'm going to do is figure out my amplitude. Remember, that's just this distance. So to go from -5 up to 15, that covered 20 units. Everybody okay there? I don't have to divide it by 2 because I don't have a max and a min. I just have, a minimum and a midline or whatever. Is that okay? So again, I'm just using a little bit of common sense to just kind of count. Amy?
So anytime you have a midpoint, is just the second function.
Is the y coordinate?
Yep.
Yep. The midline's got to be going through midpoints, right? Yes, Alonso.
Can you do number 6 on worksheet?
I would love to, but this one still has a little bit more to do. So I'm going to finish this one, but you're next. Okay? All right. So we still need to find this. What I'm going to do next is I'm going to find the C. So that means finding the period. So going from here to here looks like how much of a period? I would say a quarter, right? So this is another quarter, and then another quarter. You guys all buy that? From extreme point to midpoint is a quarter of a period. You guys cool? Make sense? Emily, you're happy?
Yeah.
Okay. And that's the horizontal distance. That's the distance between 2 and 8, which is 6. So if a fourth of a period is 6, one period has to be 24. And I know one period is 2 pi c. So, and we always use c to be positive, so that's going to be just 12 over pi. I'm just going from 2 to 8, right? I'm just counting along the x-axis, how far apart those points are. Does that feel okay? Drake? 12 over pi, you're correct. Emily, we're still doing okay? Okay. So the last thing we're going to do is decide whether to use sine or cosine, and then find the value of a, or find the sine of a and the value for h. Which one do you think we should do, sine or cosine? Well, it doesn't matter, right? Because you have a midpoint and you have an extreme point, so you could do either. Everybody's okay with that? Which one would you like to do, Emily? Okie dokie. They're no more difficult than the other. So we're going 0, 0, which is that kind of midline point. And we have to use 215 because that's the other midline point that we have. Now, here is my midline point, right? After the midline point is a minimum. So before it certainly was a maximum. If you notice the order for the midline point, what can we say? We can say that A is negative. And since the x-coordinate here is 0, the x-coordinate on the transformed is the h. And there's everything we needed.
Why is A negative in this case?
Because if you look at the order of our midline points, they're the opposite order. Ryan?
Can you go over why it's 1/4 period? It's already 1.
Well, if I look, this yellow section is what we have.
Yeah.
So if I go from extreme point back to minimum or back to the midline, that's another section that's got to be the same horizontal distance, right? And if I go from the midline to the next extreme point, I have another section that's, again, this has to be the same horizontal distance. And from that extreme point back to the midline, again, same horizontal distance. So there's 4 of those sections. So we have in one period. So this has to be like 1/4 of a period. Does that make sense?
Yeah.
Emily.
So 1/4 of the period is from midline to extreme point.
Sure. Or from one extreme point to the next extreme point. Now keep in mind like 9 where it's like the next maximum after that. So it's like more than one period in between those. But yes, in general, if you're talking about like the next one, then yes, what you said was all correct. Okay, Loretta,
Number 6 on worksheet 3.
Worksheet 3. Number 6. Okay. So these ones where we're given the graph, I think are even a little bit easier because you have all of the information possible. So almost everything I'm going to get is just going to come from looking at the picture. Only that final step where I find the H and the sign for A. Am I going to actually do anything algebraic? From here, I'm just going to be mostly just looking at the pictures. So the midline divides the graph in half like vertically. So hopefully it's easy to see that that's the midline. So that the K value is 2. Happy with that? The amplitude is just the distance from the midline to an extreme point. So the midline's at 2, that extreme point's at 5, so the amplitude would have to be 3. Feel good there? Okay. Next, I'm going to look at the period. So I'm going to go from minimum to minimum. This minimum's at negative pi. This minimum would be at 3 pi. So the period there is 4 pi. You buy that? And I know that a period is 2 pi times c. So my c here is just 2. So far, so good?
Yeah, I was confused by this.
Okay. The last thing I need is to find the h. Here we're told we're using cosine. So I'm going to use this 0.01, which is a maximum. And then I can pick either extreme point from my graph. It doesn't matter which one. For the sake of argument, let's use negative pi negative 1, which is a minimum. Because we're going from max to min. What does that tell me about A? It's got to be negative. So the A is negative 3. And what does the H have to be? Negative pi. And then I just fill in my blanks. Does that feel okay, Loretta? Yeah. Amy? So the period, I'm counting on the graph, going from one minimum to the next minimum. The first minimum happens at negative pi, and then the second one happens at 3 pi. So going from negative 1 to positive 3 is 4 units. So 4 pi. And I know that one period is 2 pi c, so I just solved that equation for c. So I divided both sides by 2 pi to get 2. Is that okay? You're welcome. Natalie.
It's kind of a stupid question, but
It's okay.
Number 5, would the A value be positive or negative?
Well, let's look at, so for this one, we would use 0, 0. And we have to use the point 0, 2, because that's the only midline point that we can read from the graph. To the left of 0, 2 is a minimum, and to the right of it is a maximum. Notice that the order of these are the same. So it tells me the A has to be positive. And the H would be 0 in this case. Edmund.
My tablet this time. Is it cool to let me know of a extreme point on the sine graph?
Yeah, so pi over 2 and 1 would be a maximum, or 3 pi over 2 and negative 1 would be a minimum. Yep, so again, these things, like totally fine that you're asking about them. They're just the key points list. So this is the biggest y coordinate, so that's a maximum. This is the smallest y coordinate, that's a minimum. You know, you could use really any of these that are on the, that have a y coordinate of 0 as a midline point. Same thing for cosine. So any of them who are the y coordinate is 1 are maxes, 0 are midlines, and 1 or -1 is a minimum. So I'm just using these guys. Does that feel okay? Eric. Okay. Let me grab that. Number 13, you say?
Yes.
Sure. And Loretta, you're good now?
Yep.
Okay. Just double checking. It felt like we had sewn that up, but I figured before I moved on, I better just double check. Yeah, of course. Okay. So the first thing I'd want to do is determine the values for A, C, H, and K, because I need those to find the amplitude, midline, period, frequency, and then I need those to write my transformation map. So that's my starting place. So before I can start picking those values off, I have to make sure that my equation is in that general form for a transformation. Namely, I need to make sure the leading coefficient on my x is 1. And that's not the case with this problem, right? The leading coefficient on my x there is 2. So I'm going to start by factoring that 2. When we factor a 2 off, we're dividing. So 2x divided by 2 is x. And pi over 2 divided by 2 is pi over 4. Because dividing by 2 is the same as multiplying by the reciprocal. So pi over 2 times a half is pi over 4. And I'll write the plus 0 there so it's really obvious what the k is. Kate. Of course, yes, no problem. So far, so good. Okay, the amplitude is the absolute value of A. Absolute value of -3 is 3. Midline is y equals k. The k is 0, so I have y equals 0. The period is 2 pi times the absolute value of c. C is 1/2, so 2 pi times a half is pi. The frequency is the reciprocal of the period, so 1 over pi. Okay with that? All right. Let's write our transformation map. So I have Cx plus h, and then ay plus k. I'm not going to bother to write the plus 0, though. So far, so good. And then I'm just going to use my key points for sine. I have these memorized. You do not need to do that. I would provide those for you if you needed them. And now all I'm going to do is take the x and plug it in there and evaluate, and take the y and plug it in there and evaluate. So that's pi over 4, 0. When I plug the pi over 2 in, that's pi over 4 plus pi over 4. So it's pi over 2. And then -3. And that's pi over 2 plus pi over 4, so that's 3 pi over 4, 0. And we have 3 pi over 4 plus 1 pi over 4, so that's positive 3. And then 5 pi over 4, 0. Notice the x-coordinates are just going up by 1/4 of pi each time, right? That'll be always the case. It'll always be the same amount that the x-coordinates are going up by. It won't always be pi over 4, but it'll be the same amount. And then we just need to graph and stuff. Edmund, what's up? Okay. So pi over 4. So if this is 0, this is pi. That must be pi over 2. So pi over 4 must be like here. Agree with that? So I had 0 pi, so this has to be half of a pi. And then half of a half pi is a quarter. So that's where the quarter mark is. And then I'm just going to start filling. So pi over 2, -3, 3/4 0, pi 3, and then 5 pi 0. And then I just kind of continue the pattern. Does that feel good?
Yeah.
You're welcome. Edmund.
Can you explain how you got the loading point and P again previously?
Yeah, so all I'm using is the information on this chart here. So the midline point is y equals k. So that was 0 in this case. And then the period is 2 pi times c, which 2 pi times a half is just pi. Good with that?
Yep.
Who's next? Enzo. Yeah, sure, no problem. In fact, I think we already have this problem on here, right? Let's find that real quick. Okay. So again, he's just asking for the period, so we're just I'm gonna sketch the picture so we can reason out where the period is. But that's all I'm gonna really do. So I have 10, -20. Let's do that. And then 46, 18. And we're told that the 10, -20 is a minimum. And the second maximum after that is the next point. So we go to a maximum, back down to a minimum, and then back up to there. Right? So I know from minimum, the next minimum is 1 period, right? And then I know from that minimum back to a maximum is another half. So this is like 1.5 periods is going to equal the distance from 10 to 46. So I could, let's just think about it this way, because it just will make life a little bit easier numerically to do that. Because then, and now I can do it in my head. All right, so if I divide both sides by 3 pi, I get 12 over pi for c. Again, choosing c to be positive. Enzo, are you happy with what we did there? Too fast, or is it okay? Okay. Again, if we need to re-explain something, holler at me. Or if I went too fast and buzzed past something, or you missed it, or whatever, you know. Or just like, hey, why'd you do that? It's okay. Those are all important questions. I'm not trying to speed past anything. Amy, are you handing?
Yeah. If you're taking like the values out of the equation that you already have, and you're looking for c, when you take it out of the equation, you need to flip it to
Yeah, so let's just do a quick aside here and do a specific example, right? So like my general form is this. So if I have Say we have something that looks like this, right? So what's my A? 3. So this is saying that 1 over C is 4, right? So C has to be the reciprocal of 4. If 1 over C is 4, then the reciprocal of 1 over C has to be the reciprocal of 4. Does that feel okay? So yes was the answer to your question. And then the H is 5 and the K is 1. Right, that's what you wanted to have cleaned up. You're welcome. I just wanted to make sure I understood what you're asking. So I wanted to do all of this just to make sure that I understood and I didn't give you, say, oh, yeah, of course, and be like, oh, no, I meant something else. And I meant something else, and I'd answered the wrong question or something. Since it wasn't about a specific route, you know what I mean? I just want to double check. Anybody else? Oh, Luke. Zach. I was gonna notice. Sorry.
Can you give an example on like, I think it was worksheet. Is there a worksheet for?
Yep. So this one we're graphing tangent stuff.
Oh wait, no, it was something from the notes. It was like when you did an example in the notes for graphing the function.
Okay.
How did you figure out what the actual is?
Oh. So let's just look at this real quick. So we did this, right? And then I drew in these asymptotes. So these points that have the y-coordinate undefined are where my asymptotes are. So negative 5 pi over 4 is here. That's where I got that asymptote. And 3 pi over 4 is here. So that's where I got that asymptote. Is that okay?
Yeah, I was just confused because I think in the video you said that the asymptotes were at like negative 5 and 3.
Oh, yeah.
I think you meant the number.
Yeah, I think I meant negative like 5 pi. Yes, for sure. I probably did misspeak there. If that's, yeah. My apologies there. Drake.
Question about number 3. Setting for 1.
So when you say number 3, which number 3?
Oh.
From a worksheet, from a problems?
Worksheet 2.
From worksheet 2. Okay.
Just like translating like the sides of side.
So I would. So did you get you've done part of this already, right? So I'm going to buzz through and just write down the values for A, C to start. And then we'll just deal with how we pull out the values for H and K and the sign for A. Is that cool?
Yes.
Okay. So we know that the absolute value of A is 4. And we know that C is 2. I just wrote those down because he's halfway through the problem already, and I just didn't want to go do it again. Is that okay? All right. So we're using, it says we have to use cosine. So I'm going to use the point 0, 1, which is a maximum. And I'm going to hook that up with negative 6, negative 9. And I'm not told whether negative 6, negative 9 is any specific kind of point. So I can put it anywhere I really want on my cosine function. Since I'm using 0, 1, I need to pick it as either a maximum or a minimum, but it doesn't really matter which one I pick. For the sake of simplicity, I'm going to choose to make that a maximum. Are you okay with that, Drake?
So they're both.
Yep.
Okay.
See, notice here it doesn't tell you what kind of point that is.
Yeah, I turned it into like negative 4. Zip up.
I mean, if you want to make -6, -9 a minimum, that's fine. Do you want to do that? Okay. That's fine. Yeah, so that would tell me the A is negative. So A is -4. Sure. Because the x-coordinate on the parent function is 0, the x-coordinate from our transform function is h. But since the y-coordinate in our parent function is not 0, we're going to have to solve for k. So to solve for k, I'm going to say a times the y from the parent function plus k needs to give us the y from our transformed function. So that's -4 times 1 plus k is equal to -6. So k is just -2. K is -2. Does that feel okay, Drake? So, nope, nope, everything is done. So just y equals a times cosine of 1 over c x minus h plus k. And you could simplify that if you wanted to, but it's done. Yes. Yep. Okay. And so. Oh, shoot. Yeah. Ha. I wrote down the wrong number there, huh? So that's going to be a -5 then, huh? Thank you, sir. Oops-a-daisy. Thank you. Okay. So you guys all know what's coming, right?
Yeah.
Okay. Pencils and calculators, and let's get this thing done, huh?